And the last one, number 10, jumps around in all the different ones and all the different time periods as well. So look, we're starting with per hour, and the personal ones, don't like using P with the probability and the, so they arrive at 1.8 per hour. We've also not got business ones arriving at 3.7 per hour, and we've got advertising ones arriving at a mean of 1.5 per hour. Find the probability at least one of each type during a 30-minute working day. So that means during 30 minutes, we're going to have, I'm going to use that. What shall I use now? 30 minutes, it's only a half of that. It's only a half of, what's a half of 3.7? 1.85. And that one there, 0.75. And what do we want? At least one. So we want the probability that this one is greater than or equal to 1 times by the probability that that one is greater than or equal to 1 times by the probability that that one is greater than or equal to 1. So multiplying all those things together, we'll work out each of those things individually. I'll do that while you pause the video. So I've just put each of those with these new means, not the original 1 hour ones, into the calculator. And we want each of these things to happen. So I times it all together and I've got 0.2639 or 264 to 3 significant figures at the end of that. For part B, more than 50 emails in an 8-hour working day. So let's do the total. So the total per hour is going to be 1.8 and 3.7 and 1.5. The total per hour is 7. In an 8-hour working day, that'll be 56. So let's make T be a Poisson with a mean of 56, much quicker. And we want more than 50. So the probability that T is greater than 50, so that's greater than or equal to 51, isn't it? Nearly got that wrong there on the very last one. Poisson greater than or equal to 51 with a mean of 56, and that's giving me, that's coloured in nicely, isn't it? Because there's such a large number, you've got quite a lot there. So 0.766. 0.766 there. Very normal distribution, isn't it? With a large number there. I'm sure there'll be a normal approximation to a Poisson later. And part C, find the probability that she receives more than 50 emails on exactly 2 days out of a 5-day working week. Hey, we've switched to a binomial. So the number of days. Days is a binomial. There's 5 days in a working week. The chance of getting more than 50 was the value we just had there. And we want the number of days that happens in exactly 2. So we've switched to a binomial. We want it to be equal to exactly, equal to 2 with 5 trials, and the probability was 0.7. It was 657, wasn't it? I put in the real value. And that gives us, let's look at it, 0.0754.